Class 12 Mathematics, we are solving the miscellaneous exercise of chapter 7, that is your integration. And now we are going to take question number 19. Here, integration of sin inverse root x minus cos inverse root x divided by sin inverse root x plus cos inverse root x with respect to x. In order to solve this, you have to use an identity of inverse trigonometric function. What's the identity? Sin inverse t plus cos inverse t equals to pi by 2. This identity to be used here before going to find out the integral. Now, if you use this identity, then you see the function becomes simple function, because what we are going to do, sin inverse root x as it is minus cos inverse root x. So cos inverse root x you can replace by pi by 2 minus sin inverse root x, because sin inverse root x plus cos inverse root x is your pi by 2. So using that we can replace it cos inverse root x divided by, can you tell me what's the denominator? It is sin inverse root x plus cos inverse root x. So that's directly you can use pi by 2. Here it is pi by 2 with respect to x dx. After this, pi by 2 is a constant, so I equals to 2 over pi integration of. And if you simplify this, twice of sin inverse root x minus pi by 2 with respect to x, that is dx. Now see, implies I equals to, just we are saying term-wise integration of first term minus integration of second term. First term is twice sin inverse root x, so it will be 2 by pi is here, 4 by pi integration of sin inverse root x dx minus pi by 2 is constant, so out of the integral sign, integration of dx. After that, I equals to 4 by pi, let us take this as I1, this much is your I1, minus, sorry, here 2 by pi is here, 2 by pi into this, 2 by pi into this also, so this pi by 2 will not be here, it will be cancelled out. 2 by pi into pi by 2, it will be cancelled out. So only dx, that will be your, it is minus integration of dx minus x, this number 1. Constant of integration, finally at last you can add it. Every step C1, C2, C3, no need to add the constant like that way. Now let us, we are left to find out I1. So now what is your I1? I1 is your integration sin inverse root x dx. Now you have to think about this only, how to find out this. So how to find out this? Using substitution method. So what to substitute? See, let x equals to sine square theta. Then this will give you dx equals to twice sine theta, cos theta and d theta. So therefore, I1 equals to integration of sine inverse, and x is your sine square theta. See, x is your sine square theta, so root x will be your simply sine theta. So in place of root x you can write sine of theta. Then dx is how much? 2 sine theta cos theta d theta, implies I1 equals to, now sine inverse of sine identity function, the integration of theta into, we know that 2 sine theta cos theta is nothing but sine of twice theta. That's why you can write 2 sine theta cos theta. You can write sine of twice theta d theta. Now again it's product of two functions. One is algebraic, another is trigonometric. So you can use bypass method to find out this. So if you use bypass method, Then I1 equals to bypass rule known to us first function as it is. Integration of second function, let me write directly. Integration of sine twice theta is what? Minus cos twice theta by 2. So into minus cos of twice theta by 2 minus, this is bypass rule we are using, derivative of first function, that is theta 1, again integration of second function, so this much will come minus cos of twice theta by 2 d theta. Finally I1 equals to, this is minus half of theta cos of twice theta, and here it is minus, so it will be plus actually 1 by 2 out, because it is cos twice theta by 2, so minus half will come out of the integral sign, that will be your plus half. Now integration of cos twice theta is what? Integration of cos twice theta sin twice theta by 2, that's why you can write here sine of twice theta by 2, this much. Again I am saying constant of integration at last you join, no need to write constant of integration c1 c2 c3 at every steps, no need to do. At last you just keep constant of integration as c. So here I1 equals to minus half of theta cos of 2 theta, it's clear I think, plus 1/4 of you take, that's your sine of twice theta, this much. Now what to do? You have to replace I1 in I, that is number 1 already given. So 1 implies, where to write? Okay, let me rub this part now. See, then 1 implies I equals to, it is your 4 by as it is, and I1 is this much, so better to use brackets, minus half of theta and cos of 2 theta, cos of twice theta, plus 1/4 of sine twice theta, this much. So what we have done, we have just replaced the value of I1, this much, and minus x as it is minus x. Ultimately we have to transform theta in terms of x also. Now that part is left. Now you see 4 by pi into minus 1 by 2, that will be minus 2 by pi theta cos of twice theta, we can write what? 1 minus 2 sine square theta. So let us do this. 1 minus 2 sine square theta plus 4 by pi into 1 by 4. That will be your 1 by pi. Sine of twice theta you can write 2 sine theta cos theta. And minus x is here already. So minus x, here it is minus x. Now final step, minus 2 by pi. Now what is theta? Because you say x is your sine square theta, then theta will be what? From here you can find out sine theta is your root x, sine square theta x, so sine theta root x, and theta is your sine inverse of root x. So let me write theta is your sine inverse root x. Within brackets 1 minus 2, don't write x square because sine square theta itself x. So simply write 2 sine x plus 2 by pi. Now you see it is sine theta. So sine theta simply root x. So I will write here root x. Now from where to get the value of cos theta? Cos theta equal to under root over 1 minus sine square theta. So under root over 1 minus sin square theta. Here is a chance of mistake, because sin square theta itself x, and it has been seen many students by mistake they are writing x square. It is, remember, sin square theta is itself x. So root over 1 minus sin square theta. So here it is simply 1 minus x will come, a plus minus x. So finally, you can write 2 by pi here, positive term let us take at first. 2 by pi under root over x into 1 minus x, that's your x minus x square, and minus 2 by pi sin inverse root over x, 2 by pi sin inverse root over x. Let me write this way, 2 by pi 1 minus 2x, here you write 1 minus 2x, 2 minus 2 by pi into 1 minus 2x, sin inverse root x as it is, sin inverse root x, and minus x, and at last you can now give the constant of integration plus c, and in your textbook answer is given in this form. I hope the solution is clear to you. Let us take the next question now.